On behalf of Schneider Electric, I'd like to wish everybody a happy new year and thank you for tuning in to the first 6 episodes of Practitioners Unplugged for 2024. Also like to thank our guests that have attended and supported this and allowed the podcast to grow. We're looking forward to another year of bringing you more stories from the digital transformation front lines.
And on behalf of Aviva, thanks again for all the support and a happy new year to you as well.
Hello, everybody, and welcome back to Practitioners Unplugged podcast, where we dive into real-world stories and strategies of manufacturing digital transformation. Join us as we hear from thought leaders and innovators who are driving change and shaping the future of Industry 4.0. Whether you're a seasoned professional or just curious about the future of manufacturing, this podcast is for you. Today on episode 6, we're honored to have Jonathan Weiss with us. Jonathan is a vice president of technology and chief technology architect at the Clean Energy Smart Manufacturing Innovation Institute, otherwise known as CESMII. CESMII is a US-based nonprofit dedicated to smart manufacturing, working to reduce cost, complexity, and time to value so that all manufacturers can engage in smart manufacturing. Jonathan has been with CESMII since July of 2019. With a robust career at industry giants such as Rockwell, Amazon, Microsoft, GE, and ActivePlan, Jonathan has developed a rare blend of OT and IT experience. He plays a pivotal role in driving CESMII's smart manufacturing platform, focusing on integrating operations and information technologies to democratize smart manufacturing for U.S. manufacturers. Jonathan, welcome to the podcast. Is there anything that you'd like to, is there anything else you'd like to add about your background?
I think that's pretty good. I spent about 10 years writing software and then another 10 in product and business management related to software. Most of it focused on manufacturing. So I live and breathe this space every day, for better or worse. Great to be here chatting about this with you.
Yeah, Jonathan, I think we're pretty excited to have you because I think given the blend of the operations business side and the technical side, you're one of our first guests who can straddle both of those, both sides of the equation. So one thing I noticed that really got my attention when CESMII describes their mission, or one of their goals is to empower the frictionless movement of information, and I'll read this: raw and contextualized data between real-time operations and the people and systems that create value in and across industrial supply chains. So, no better way to say that, right? It's very succinct. As in your role, I understand that you led the development of a smart manufacturing innovation platform. So could you share a little bit about that? The word platform means many things, right? So,
sure. Yeah, and maybe we have a couple of meanings for it, and maybe they're different than most people are thinking. So CESMII is not a commercial entity. We don't have a product to sell. We don't build products to sell. We do partner with members who are vendors in this space, but we are a public-private partnership, largely funded by the Department of Energy. Our focus is in the name: clean energy and smart manufacturing. And kind of the impetus is on this particular topic, manufacturers can be smarter if they have better access to their information. Raw data isn't information. We need to liberate that and get it moving. We need to preserve and protect the context associated with that data because it's critical to making good decisions. But we also need to surface that information to, in general, an agent, a person or an AI or an algorithm that can act on that information. So the smart manufacturing innovation, or sometimes interoperability platform, is really two things. One, it's a set of ideas that any platform vendor can implement that we think would help make their platform smarter, help make their users able to make better decisions. And then the other that we used for most of the last 5 years was a particular implementation of those ideas by our members, real actual software that some of them sell. We don't sell it, but they sell it that we use as sort of the tip of the spear at exploring these ideas, and then as the foundation for projects that we wanted to see accelerated in our space. So for each of these projects, I think there were more than 50, 58 is that number that's kind of in my head. All of them used this implementation of those ideas as their foundation. So they didn't have to build up an information platform first. They could focus on the information problem that they were trying to solve. Even though that was kind of what we led with for the past 5 years, really the goal has always been to float all boats. There's a number of players in our space that have information offerings or information tools. So how can we help all of them kind of level up, be closer to smart, so that their end users, wherever they are, can be enabled to make better, smarter decisions.
Got it. So, the technical, I'm a non-technical person. The technical side can be a little bit hard to grasp. So let me phrase it this way. So let's say I'm the somebody who is championing, an executive championing smart manufacturing transformation within an organization. So today I know that I'm using a bunch of apps, point solutions, maybe some platforms from multiple vendors to enable the smart manufacturing evolution. How will I know whether I have a good platform strategy or not, right?
I think the legacy that our space has offered to you as an executive at a manufacturer does not lend itself to a good smart platform. As a general truism in our space, each app that you choose to use carries its own platform with it. This is out of necessity. Getting access to manufacturing data is hard for good reasons and for historical reasons that aren't as good. And so everybody who wants to offer one of those points of value in our space, an app that solves a particular problem, needs to bring with them an approach to comms, an approach to data acquisition, an approach to data storage, an approach to an application platform, and then finally their app themselves. And this is true across the big vendors and across the small ones. Everybody has to solve all of those problems all of the time. Even within a big vendor like Rockwell, their portfolio of applications is largely heterogeneous. Each application brings its own platform. There is no common platform that all of those applications build against. So what that means for you as a manufacturing executive when you're choosing software that you hope will help you solve a problem is that your agility is limited by the long integration cycles necessary for each of those applications to get fully plugged in and establish their stack before they can return information value to you. We end up with a lot of projects in pilot purgatory because the proposed value is simple and understandable, but the exercise of deploying the application and its underlying platform to get to that value is long and difficult and 100% not repeatable, because the next application you want to buy to solve a different problem is going to go through that same exercise. This is the number one point of friction when we talk about app value, like smart decision making. Is it's not like our smartphones where I can easily install an app, try it out, see if it works for me, and remove the app. Everything that I want to try in my space, everything that I want to iterate on as a smart manufacturing executive to see if it helps me get smarter is painful and takes a long time to deploy.
So scalability is a major theme here, right? Scalability, using standards so you can actually get to value faster.
Scalability
right?
and repeatability.
Scalability and repeatability.
Or once, and I have to go through that same pain to deploy it in another facility or elsewhere in my enterprise, that's a scalability problem. A repeatability problem is that application can't be redeployed against another stack. It must bring its stack with us. The applications themselves are not repeatable, separate from the platform, the underlying platform they bring with them.
Yeah. So when I look at the process side of this transformation, there's a lot of appetite for a crawl, walk, run journey. And so, for example, when we look at, again, purely from the process perspective, crawl is seen as I'm doing a lot of firefighting. Walk is seen as, all right, I've gotten to a level of like disciplined execution where I actually know what I need to do to have a good day or a good shift. And then that run is, from there you're building on for, let's say whether you want flexibility, agility, some of the more, advanced capabilities, of the system. Do you see a similar maturity from a platform perspective? Or is that something you have to design from the end in mind? And
No, I mean, I think just in other words, you're talking about being reactive, proactive, or prescriptive, right? And this is very much kind of an analytic journey. I start diagnostic, I moved to predictive, and then I finally get to prescriptive, where the analytic can make decisions and implement the decisions in real time or close to real time. And that's 100% true of probably all of the 58 projects that we sponsored. They're all starting from somewhere, right? And generally they're reactive and they want to get to proactive or to predictive, whatever the information problem is that they're trying to solve. So yes, to your question, yes, I think that's true. It's also true when I'm kind of defining an architecture for my software. If I start with a point of light, which is a fine place to start, like here's one problem that I want to solve or one thing that I want to be able to get ahead of. If I start out that architecture thinking only of how I'm going to support that one application, that one point of light, the next time I have a problem I want to solve or an application I want to deploy or an algorithm I want to try out, if I have to repeat the entire exercise, then I remain reactive, right? If I pause a little and think from the outset, how am I, one, going to solve this problem, but two, and maybe more importantly, establish a foundation for solving lots of different problems in the future, then I can kind of move up this maturity curve in my architecture where I'm able to be more agile and maybe even more proactive in my design so that I can support a wider array of points of light, problems that I want to solve, applications that I want to deploy in the future.
So essentially degrees of repeatability and scalability as that crawl, walk, run, as I get better at it.
Yeah, and it might be useful to characterize that first step as crawl, because one of our instincts in the OT level is just to solve the problem that's in front of us. Don't think through an architecture that's navel gazing or that's a waste of time. Let's just solve this problem and move on to the next one. And that can be fine once or twice, but when you end up with an architecture that is made up of just point solutions to individual problems, you have no hope of moving towards a cohesive, contextualized architecture.
Yep. So I think it's within this context, we now have this concept of a unified namespace, right? What's your view? How would you see it? How would you define it? What's CESMII's perspective of the unified namespace?
I think that's a perfect pivot point in the conversation. So if the OT instinct, at least from a software development perspective, is just solve individual problems as they crop up and move to the next one, the IT instinct, the discipline that we learn in software development, is not to do that generally. That's like a hacker approach. It's to think about an architecture, think about your class definitions, and finally think about your namespace or even the address space in which these things will exist. So what I think UNS brought to the conversation that is really useful is this language that suggests a pause, that suggests thoughtfulness about how you're going to construct effectively your information architecture. It's a word, namespace is not a word we often use in OT software. It comes from IT software. And maybe we, as a critique, maybe we haven't fully implemented it right in the OT world, but it's a truly useful exercise to think about your namespaces as one of the parts of an information architecture that you need to get right at the outset.
So I have to say that, as we've been digesting the concept of, unified namespace, I think if I were to reflect on Aviva's view, I think there's a couple of questions or a couple of challenges for us, or goals, I should say. Are we seeing this from the customer perspective? So when we go and engage and have these conversations, there is quite a bit of, let's say, there's traction around the label, but there's also some confusion because of its vagueness or newness, right? Then I think the second goal is asking ourselves, are we adding clarity or are we adding to the confusion, right? So in this context, I've spent, a lot of time on the IT side, and just in the last, decade, I've been on the OT side. Something that I have a little bit of difficulty with the label, this unified, because there's been many unification initiatives at different parts, of the value chain. There's unification efforts in design, in sourcing, making, logistics, selling, CR, and you have PLM, CRM, and all these different platforms that have helped harmonize a lot of, let's say, disparate namespaces and bring that together. So unification seems to be, or the U of UNS is not new. But maybe it's the context that, within manufacturing, it's been a, let's say, it's been a more daunting challenge in the manufacturing landscape. So what's your thoughts there? The word
around the word unification. Maybe to address your first point, which I think is important, is there customer value in this UNS idea? We solve problems in software through abstraction, and UNS is an abstraction. If I only ever solve one problem once, abstraction is overhead. So from a customer perspective, pitching the value of a namespace exercise probably doesn't make a ton of sense the first time you do this. If I only ever needed to turn on one light, one time, anywhere in the world, there would be no value in inventing the light switch. I would just twist the two wires together and turn the circuit on. The light is on and I can move on. The problem is solved. Standards, abstraction and then standards come in when I need to turn on multiple lights and then maybe to turn some lights off. And I need to do this the same all around the country, or maybe one day all around the globe. I need users to understand how to interact with that interface. And I don't ever want people grabbing wires and twisting them together. I want a safe abstraction from the electricity. UNS is an abstraction from the data source, and a light switch is an application on top of that abstraction. It is an interface that a user can understand how to interact with that shields them from the complexity of the wiring in their house or in their office building. It does have value, but the first time you look at a problem, it may seem like an extra exercise. But there's a really important thing that you're probing at there that is true in the analogy as well, is that standards become really important if I need to use that abstraction somewhere else. If I invented a light switch that only worked in my house, that would be very clever. But if I went to somebody else's house and they had a completely different way of interacting with the electricity at their house, I wouldn't have a standard, I wouldn't have a unification, and the abstraction is really only moving the problem up a layer. I don't have to understand the wiring in their house, but I have to understand their abstraction, their implementation of the interface, because everybody makes their own. So a unified namespace is a useful exercise in abstracting the raw data into a more understandable interface, but it becomes much more valuable if we can standardize on what those interfaces look like, if we can do some actual unification, and if that unification happens beyond individual teams, individual companies, but leverages international or at least cross-industry vertical standards.
So then it would be fair to say that if we do the UNS exercise correct, we will actually end up reducing technical debt, which is a serious problem today.
Yes, right? And if we do it wrong, if we do it in a vacuum, we are guaranteed to create new technical debt, especially when we want to work with a new partner or a new supplier, or we acquire another company that has their own UNS. Then the technical debt piles up the longer individual teams create individual non-unified UNSs.
Yeah. So before we dive into, let's say, a UNS in the context of manufacturing, I was reflecting on the fact that, we've done this harmonization exercise many times. And what did we learn from these experiences, whether it was the evolution of supply chain around the harmonization of orders, PLM around the harmonization of different product-related information. And, 3 types of problem areas sort of popped out, right? And I would say one problem, I would describe this as the ontology problem, right? And if I think of, a job and a skill set, it's a lot like a librarian, right? And you have to have some level of subject matter expertise to do a good job of the ontology problem. The second problem, I'm using the word, it's a composition problem, because you're creating some kind of a view or report, or there's a consumer of that data product, right? And for them, depending on whether they're in quality or in supply chain or a higher level position, how you compose those things, right? It's like data, like orchestration and composition. And then the third problem is I'm calling it the broker problem, right? It's about secure and timely transportation from source to consumption. And that's a different skill set, right? So you could say that the composition problem doesn't really have a skill set, because I'm just the consumer of the information. But the ontology problem, or at least effectively tackling these UNS projects, requires a group of people with the ontology skill set and a people with the skill set that's for the broker/transportation problem. Does that make sense? Yeah.
Yes, and we should hit each of those. So poke me if I miss one. But what I want to call out that I think is useful about a UNS exercise, what CESMII would call a profiling exercise, is the drawing together of the disciplines. If it's done right. If you have an OT team that thinks, hey, we got this, we can define our namespace or our profile on our own, we don't need to listen to experts, you're going to have a problem. Similarly, if you have a bunch of experts that think they have a good namespace or a good profile, in our words, but they've never talked to a practitioner within the OT world, and they end up making something theoretical and so abstract that nobody can actually use it, they've also wasted their time. So done right, this exercise does draw those 2 disciplines together. It probably should start ontologically. It probably should start with the subject matter experts defining what they think the namespace should look like or the profile should look like. And then kind of the OT practitioner shooting holes in it, saying, yeah, we have that's real in the real world and we can implement that, or that's not real, we can't implement that, which begs the question, can it not be implemented because the deep thinking theoreticians don't actually understand the process that's being done, or because the underlying equipment doesn't have the instrumentation necessary to fulfill the profile or fulfill the namespace? And that's a good, healthy tension and conversation. It can go the other way. It can be like, here's OT saying, here's the data we have and what we call it, and a subject matter expert making adjustments. It can go that way as well. But however you approach it, I obviously have my preference. However you approach it, it should be a healthy interaction between the 2, trying to come up with a namespace that is validated, is fulfillable on either side. the subject matter expert, the reason I have a bias there is because as a subject matter expert, you are more likely to be aware of what standards exist in the space, what prior art you can leverage, what published work might be applicable to your space. We find that if OT teams try to do that within a vacuum, they don't have that kind of exposure to the other work that's being done, and they end up reinventing the wheel or being like myopically problem focused, not arriving at a namespace that is standards based or repeatable. It's not 100% true, right? You can have great OT teams. You can also have or subject matter experts, but whatever kind of your combination is, both need to be present and both need to work together on defining a namespace or profile that is actually useful. The other point that can't be understated is that some of these namespaces already exist and have been defined by subject matter experts. There is a corpus of 160 OPC UA companion specifications, which include as part of their definition a profile or a namespace that is applicable to a manufacturing problem. So to just ignore that body of work, that set of subject matter expertise, and think that the local team knows better than professional teams around the world who have put together working groups to publish these things is foolish. It's a mistake. You should at least be informed by the work that they've done. The composition problem is really a strength of this approach. So unified namespace implies that there is one. In no software is there a single namespace. Maybe within a library, but most libraries depend on other libraries that also bring their own namespaces. A namespace is not a monolith. A namespace is composed of other namespaces. And when I instantiate that namespace, meaning it begins to exist in real time instead of in the abstract as a definition, but it's actually implemented by objects, the namespace expands to what we would call an address space that includes instance objects derived from the namespace. The name UNS is a good one for a lot of reasons that we've talked about. It's challenging for those who don't fully understand what a namespace is if they get stuck thinking they have to have just one. In fact, composition is a strength of this approach. We can compose our namespace of other namespaces, each of those component namespaces potentially serving different constituents or different use cases. Maintenance may have a different view or need a different namespace for the data than business planning or than process design, right? There's all these different personas, and they can be served with composition as much as possible. There should be internal harmonization. The composed namespace should be derived from professionally created subject matter expertise namespaces. But composition is not a weakness of this approach. It's a strength. And then broker problem, maybe say more and we can talk more about that one.
Well, it seems like the composition problem that's tied to the business case, how you want to create value. And then that will also, let's say, highlight the issues you may have with ontology.
Sure.
And then you look at those together, that will then tell you how you want to approach the broker problem, right? How real time.
If I end up composing things that are not harmonious, that don't work together, there's either an ontological discussion or an implementation discussion that needs to happen. Okay, but then your segue to the broker problem.
Yeah, I mean, we can jump into the broker side, I guess. But when we talk about all this, a lot of the talk around the UNS is based upon MQTT implementations, the UNS, right? So is that the end all be all as far as like the data transport mechanism is considered, or are there alternatives? Is it viable? Like, what are the drawbacks that we see around that part?
I think it was a mistake for the proponents of this idea to tightly couple the idea with MQTT as the transport. And I should preface that by saying I'm a fan of MQTT. It is the fastest way to explore these ideas. literally go from sensor to a namespace in 10 minutes in a way that you can see what's happening. It's powerful, it's easy to use, it's important, but not every UNS requires an MQTT broker. In fact, the UNS folks are borrowing the term namespace from technologies that predate MQTT, that have been implemented better than MQTT is capable of implementing. Yes, you can do it with MQTT. It's going to require extra tools and extra discipline because of the flexibility of MQTT. And if that's your choice for whatever reason, that's fine. But you don't need MQTT to define a UNS. In fact, arguably, there are places you can do it better.
And what would those places look like? So you said it has to have extra discipline, right? So let's dive into both of those. From the technical aspect, when we talk about the discipline need to successfully scale MQTT versus what are the alternatives out and what's better? Or not better, but there's always a give and take between each one. It's dependent on the situation, obviously, right?
So I'll quote the co-inventor of MQTT while advocating for SparkPlug-B. And I'll probably not get the quote perfect, but the power of MQTT is that a payload can be anything. The problem with MQTT is that a payload can be anything. I can declare that a namespace should be a certain way, and I can ask all of the publishers to the broker to respect that namespace, but I cannot, with MQTT itself, guarantee that all participants will respect that namespace. I need additions to MQTT to ensure that that happens. Some of the vendors have noticed this problem and brought things like JSON schema to their brokers to help enforce a namespace. But the reality is that this namespace concept is not a part of the MQTT spec. It's not even really a part of the SparkPlug-B spec, although SparkPlug-B provides a lot more tools for effectively type safety, type discovery and type safety. But namespaces themselves don't exist within MQTT. So what that means is that as a team that's adopted MQTT as a broker in particular, as the authoritative home of the implementation of the UNS, is that you need to assemble additional tools or additional discipline to help make that unification and that namespace really happen. Other protocols don't suffer from this problem. Arguably, they bring their own set of problems to the table. But in OPC UA, a good OPC UA implementation travels with the type definitions and the instance objects. And it's a true statement, in fact, that all OPC UA data is of a type, and the type is on board. The problematic approach is that many of the instances are of the type base object class, right? They haven't used the type safety of OPC UA the way they should. And OPC UA has its other challenges, but one of its weaknesses is not lack of type safety, which is one of the weaknesses of MQTT. I'm not actually saying you should pick one or the other. I'm saying that the namespace concept, when coupled with MQTT, brings extra work that has to be considered if you're gonna couple the two.
Yeah, that's a fair point. Now, I think one of the allures around MQTT, which I agree with you is a good transport, is really the limits on the bandwidth when you start to get large, piles of data publishing through the system. OPC has a little bit more overhead and let's say more knowledge to setting up those standards. So what are the trade-offs, I guess, on scalability between both approaches?
Yeah, MQTT can also be very verbose. OPC UA brings a default level of verboseness, but you could do MQTT verbosely and end up with very large JSON payloads that are no less inefficient than OPC UA is. You can also do OPC UA over MQTT. So you can take their serialization and their pub sub and publish it over a vanilla MQTT broker. So some of the arguments there are a little bit artificial. Sparkplug brings a binary encoding, which is definitely more efficient over the wire. My payload can be whatever I want it to be, and I binary encode it, and it makes it much, much smaller. OPC TCP is binary encoded, or it can be binary encoded, but it's client server. So I don't get the pub sub. If I want pub sub with OPC UA, I end up using a verbose MQTT payload. A really cool combination might be OPC UA over Sparkplug, which I know some people are considering. But a lot of these trade-offs, I think, are really optimizations, and they are secondary to this namespace discussion. The namespace exercise is a worthwhile one. At some point, with high volumes of data, an optimization discussion is a worthwhile one. But again, tangling them up together and saying I don't have a UNS unless I'm doing a Sparkplug binary transmission is a faulty statement. It's a incorrect statement. The exercise of creating a unified namespace, a truly unified namespace, properly informed by external work, is worthwhile on its own, regardless of how I choose to transport the data.
Yeah, I think that's part of the issue is overcoming the initial technical debt, right? Everybody has a lot of investments already made, or back to your previous point, people have gone through the application. I have a specific app for this. So there's really no way to kind of circle back to that initial state, right? So how do you see companies justifying trying to redo stuff or getting back to those first principles on naming conventions before they start one of these endeavors without actually being able to prove any tangible ROI from just naming standardization?
I think a lot of the big companies, regardless of whether they've consumed the UNS Kool-Aid and are excited about that path, or they've come in from another angle. I think that for years, CESMII talked about profiling, and we didn't entangle it with UNS. Really, we're talking about the same thing. But regardless of how you arrived at this decision point, is this going to be worth it? For big companies, it's probably less about what they read on social media and more about that technical debt. We want to modernize. We want the power of AI. We have a big data strategy, but all of our data sources are disparate. All of our data sources name the data differently. None of our applications work together. And in order for us to move forward, we're going to have to do some cleanup. And that then is informed by what we read on social media. Maybe this is the path to cleaning up. So I think for the big companies, it's the weight of technical debt finally catching up with them. That's the impetus for having this discussion, doing this exercise. For the small companies, they will head down a path that leads to technical debt without help, because there are so many vendors out there offering point solutions. And when you're running on instinct or with limited budgets, or you just have a really strong felt need that you have to fix now, you won't do a unified namespace or profiling or an exercise to understand standards that are applicable in your space. You'll just buy from the most convincing salesperson that tells you he can solve your felt need right now. Another true statement about almost all of our 58 projects is that CESMII, had to throw on the brakes reactively initially, but now proactively towards kind of the end of our initial funding cycle, and make sure every team stops and has the right amount of time to think about their information model, their namespace, their profile, whatever you want to call it, to make them take on this exercise. Because we know if you don't do it up front, you will pay for it later, multiplied by the number of non-interoperable, non-unified point solutions you've deployed.
Yeah, it's good to hear that type of pragmatic approach now at the beginning. And I think with smaller companies that don't have a comprehensive data strategy that's centralized manner, most of the technology implemented is a response to some sort of fire that happened on the manufacturing floor. And they basically Googled problem, get point solution through you, and let's go evaluate these and put it in. So there's really, it's like, okay, short-term problem solved. But I think one of the compelling reasons for getting into this unified namespace concept right now is really getting into, you talked about it earlier, when we get into this prescriptive realm and leveraging, all this data from different places, commonly shared, commonly accessed, and then training that onto AI. So what is now, everybody may or may not approach Industry 4.0, with a different lens. And maybe it was, hey, let's just do point cloud solutions. Let's get some sensors or MQTT broker and start to look at some trends. But now we want to get into modeling, right? So what changes now on the importance of this concept now that AI is everywhere and every CEO is talking about it?
One of the cool things about CESMII is we're actually housed within UCLA's Office of Advanced Research Computing. So while we have a team that's thinking deeply about the manufacturing problem space, our parent organization is made up of a team of really smart people with PhDs that are thinking about computing in general. And right now, you can't not be thinking about AI. The the most recent excitement in AI is around generative AI, in particular large language models. Large language models benefit from a couple of the things that we've been talking about. First of all, there is an understood semantic to any language. A lot of the corpus of material is the English language, and although the English language has lots of exceptions to its rules, generally, our words have a fairly consistent semantic integrity. A word generally means what everybody else agrees it means. That semantic consistency, which is a part of a UNS effort or a profiling effort, doesn't exist in manufacturing. Our data sources are whatever the data provider chose to label them. So they're PLC tags that may or may not follow ISA 88 in their naming convention. But even if they do, the words between the underscores are whatever the PLC programmer decided they should be. There is no semantic consistency across implementations within industry in general, but often within a company. You go from plant to plant, and words don't even mean the same things. A large language model really depends on words meaning roughly the same things, because those words become tokens that it's later going to regurgitate when it tries to put together a sentence that makes sense. The other thing large language models really benefit from is the relationship between those tokens. Here again, our space is sorely lacking. Relationships are implicit in our software. The cause and effect between a PLC tag e_stop_press and the memory location in the machine that is invoked or is toggled when the PLC chooses to write to that machine is implicit in the PLC code. It is not explicitly discoverable by software. The relationship between an operator on a machine and the mutation when one operator goes home and another operator takes over operating the machine may be implicit in some scheduling software somewhere, but it is rarely explicitly discoverable by an AI. The two things that are most important, arguably most important, to the current revolution, I say that a little tongue-in-cheek, the current state of AI, semantic reliability, and the discoverability of relationships are omitted in our space. They're not there. They're not discoverable. They're not crawlable or walkable or trainable or learnable. Our corpus is garbage, and garbage in, garbage out. This is the reality of AI, at least until AI becomes magical and can translate that garbage for us. We need a unified namespace. We need those namespaces to be unified beyond individual teams. so that we can let AI loose on semantically consistent data with discoverable relationships so that we can get to AI in our space.
Without going back and renaming all your PLC tags, like what can people do to kind of, what's that? Is there a vaporware in between that you can kind of control those tags? What does that look like if we can't go in and just read or change everything out?
Change everything out. There's going to be multiple steps to solve. And one of them is middleware in between. Every software problem can be solved with another layer of abstraction. A UNS, like we talked about, is an abstraction. So it is an attempt to harness that chaos into a single point where I can find what is supposed to be true. People who are doing this with just a broker end up using multiple brokers. There is a broker that receives whatever the machine or sensor or publisher wants to call the data. There's some smart translator or model enforcer, like HighByte as an example, that I use to coerce the data into the desired format. And then there's often another broker that I republish to with the data made sense of. Arguably, you could use the same broker in just a different topic tree for the clean data than the topic trees, so the messy data. But that's what people are trying to do with MQTT, is gather the data in whatever format it comes in, with whatever semantic is built into that data source, and re-articulate it in a clean way. This then introduces kind of some of the other constraints of MQTT is designed, is as a single point of truth for the namespace. It's only true once it's published. It is only true when it's regularly published. It is only historically true if the retain flag is turned on. And it's only true if I know how to interact with the broker as a subscriber, because really that's the only other role allowed to me in the spec. So people have to add additional software, like I'm going to store historical values here, and I'm going to add an API layer here, and I'm going to add security here. And they end up like creating this kind of Frankenstein architecture around the UNS broker, around the hub in the hub and spoke model, to augment what the hub doesn't by itself give you. And the real danger there is that, well, MQTT or Sparkplug, if you choose to use that as your encoding, are a standard, are open, and that those teams have worked diligently to keep them open. The things you glom around it to add to the standard are usually proprietary. They're usually a part of some vendor's lock-in strategy. So while your core might be pure, your core can't do enough to serve all of our needs in this space. So you end up with an impure architecture of these other pieces that are going to trap you at some point in the future.
So how does that scale out, right? So if let's say we want to add, so we add other stuff, we incorporate new companies in, or how many like points of failure are we now introducing into this?
Right. How many points of failure do we end up with? A really good team at an automotive that I work with has narrowed it down to 3. So there's a UNS broker at the center, and then there are 2 other kind of critical dependencies that are in there: historical data and hierarchy service, which really informs the UNS. And then the broker they've chosen includes proprietary add-ons for security. So they've narrowed it down to 3. And that's maybe an ideal outcome, is, kind of 3 points of failure that we can introduce redundancy for and make sure we have backups for. And that's a manageable universe. CESMII's actually proposed that that space is probably going to be fluid for a while. We're going to see innovation in that space. And we've proposed one more layer of abstraction that is a standard API. So regardless of how you choose to assemble the necessary capabilities, and regardless of whether you use MQTT as your transport, if we can have a consistent API across that conglomeration of bits that abstracts the software from how you assemble your bits or how you might swap them in the future, then we actually have something that begins to look like a modern software development platform. It begins to look like, iOS or Android development. The platform could be anybody's, but it supports some critical primitives that everybody must implement. And those critical primitives have to be fulfilled by whatever pieces you choose to put below them. A UNS plus a standard API, now we're starting to look like, I should rewind, a good UNS and a standard API. Now we're starting to look like a modern software development platform that we could unleash AI on to learn from and hopefully return some value from.
So, Jonathan, I'm kind of mindful of the time here. It seems to me that there is a real need for some kind of an ongoing clinic. Because let's face it, all the stakeholders involved, we all have our own agendas, right? But I think that there is a need to understand the trade-offs upfront, right? Yeah. And facilitating that conversation around trade-offs, you need somebody who has sort of the least, or a neutral party, right?
Yeah. Yeah.
And saying that, look, you have certain, you're going down a path with certain vendors, there's no one prescribed way to do this, but understand the trade-offs and to have those conversations, because I keep thinking about all the different transformation journeys our customers are going through. Wow, I mean, just the multiple dimensions, the challenges around finding talent, which are the business processes, what are the use cases you prioritize, and this whole technical discussion is another complex dimension added to this. And instead of, prescribing something, I think the best we can do for our customers is to say, here's a forum where you can actually engage with and understand those trade-offs. What's the pros and cons? And then, you go do what you think is right for you based on your business priorities, right?
I think you're 100% right. And that is what CESMII is trying to be here in the US. We are partnered with two other organizations that have a similar focus in Europe, LNI 4.0, Labs National Industrial 4.0, and in Japan, JRR, Japan's Robot Revolution. Both of those, as well as CESMII, are consortia without a product to sell. So we don't have this bias of, we'll talk to you about these concepts, but we really just want you to buy our stuff. We don't have anything to buy. We do have a membership model, so it would be great if you would sign up as members, but we'll actually have these conversations with members and non-members alike, because you're right, this floats all boats, and different manufacturers, different kind of constituents of this space are arriving at kind of different points of maturity. Some of CESMII's members are very, very mature. They have things to teach us, and they help other members. Some of our members are small mom and pop manufacturers, and they're just exploring some of their first connectivity. And so we want to make sure they do that in a way that is scalable and repeatable so they don't trap themselves. You can be dubious about consortia, because I am. I sit on a lot of working groups, and some of them are more effective than others. But we just had our annual meeting. We had it at Oak Ridge National Labs, which is a really cool historic facility. We had 240 attendees there. We would have had more, except the facility had limits. And we maybe for, if not the first time, the best time, had that exact collaboration. We had an executive council of 50 some odd large manufacturers who are distilling kind of what must be true for manufacturers of all sizes. We had technical sessions where people were interacting with these very ideas that we're talking about. And it wasn't me lecturing. Like, I had slides to drive the conversation, but I had a big window manufacturer stand up and share with the rest of the group their experiences in trying to arrive at a unified namespace. We had small manufacturers asking questions in the room. We were having these collaborations. They're hard to do over like Zoom or Teams. We have interest groups, we have working groups, but you really have to be like motivated and self-starting to chime in on one of these calls. But these three organizations, CESMII in the US, LNI in Europe, and JRR in Japan, also held a pre-meeting at the same facility where we announced some harmonization on information modeling standards that all three agreed to advocate in kind of our realm of interest. So all of that to affirm what you said, yes, we need organizations like this. And yes, we need manufacturers to participate because they can help others on their journey and they can learn from others who are maybe further along on their journey.
Yeah, I think it's good to go ahead.
No, I was going to say that I'm really excited that Schneider is going to be part of or getting actively involved in CESMII. There's a lot for both parties to contribute to and gain from.
Agreed. Yeah, and even before you were members, you guys are in a good position, I think, on kind of standard support. You have some really impressive software in your tool belt. So we've been using your stuff in projects and trying to help people find kind of best practices. So having formal participation is really welcome.
Yeah, I think one of the other reasons we want to be in that participation is we just want to see what end users require, right? So we can develop software and what we think the market needs. There's always the theoretical way of, hey, this is what people want, but getting that feedback from, those organizations is critical, right? What's working well, what's not, what do we want to see change and why? And just having those debates because it helps steer our innovation the way that the market wants to take it and not just the way that, we feel it should go.
Yeah, and on that topic, if I could share with you and your listeners one insight from the Executive Council. They did a kind of a series of deep dives on what must be true, but on the technical one, the voice of 50 of the largest manufacturers in the US, customers, was we need interoperable software. No one vendor can solve all of our needs. We are going to have heterogeneous architectures for the foreseeable future. So we need you guys to be able to interoperate on data. You can differentiate, like by all means, show us what's best about your solution. But for the places we don't choose you or where you don't have an offering, we need what we buy from you to work with what we buy from someone else.
Yeah, and I think that's key into the future. I mean, we're making strides in that generation, still a little new with like our newer technology, like EAE, for example, but I think we're a long way out before that goes across the board, right, and gets mass adoption. It looks promising for now, but we'll see how it goes.
It's not our instinct as like software companies or hardware companies. We want our platforms to be the best one, and that's like a good pursuit. But I think we have to acknowledge that none of us is going to become like Apple and be able to own an entire ecosystem top to bottom. Our customers need to build their ecosystem out of the parts that they choose.
Yeah, and carrying all kinds of legacy stuff with mergers and acquisition, there's never going to be this utopian infrastructure that you just invest in where everything works and it's right. One software, one pane of glass, and that interoperability definitely well heard. Well, I know we're running short on time here. Just one last question for you, and then we'll get into wrap up. But any advice what are your recommendations for, let's say, a manufacturer now either investing into this endeavor, about to plan a capital, let's call it a capital project to upgrade automation, control systems, SCADA, using not in-house resources, but going external? Like, what recommendations would you have for them on if they have partners such as SIs, what standards should they adopt and why? How should they go about taking data first into the design as opposed to let's just get this machine in and get it running?
Yeah. First of all, be wary of any supplier, SI vendor who tells you you must choose a particular technology to arrive at a unified namespace. That's not a true statement, and that suggests that participant in this effort isn't well educated on what else is out there. So regardless of their particular religion or preference around protocols, that's actually not important. What's important is that your supplier, the person that you're working with, has a well-rounded view of what's happening in the industry, not just one particular view that they want to espouse. Second, before anyone starts information modeling, whether it's you in-house or a vendor, you need to look at the published corpus. Corpus is like an academic word. Published is sort of an academic word. It sounds scary or daunting, particularly if you've come up from a non-academic world. But there's a reason that these published works exist, and it's because expert teams have already thought about your problem space. You can read what they've done and choose to reject it in whole or in part, but you should at least be informed by the expert work that's been done in your space. It's foolish not to. I think third, there are organizations, there are individuals who can be guides for you. Like I said, be wary of ones that have only one viewpoint or have like ardent religion in one direction. But your design team isn't necessarily your implementation team. The folks you choose to implement your solution, the technology that you choose to leverage for it, the particular products that you want to buy, those decisions should all come after this thought exercise on what is your information model, what are you going to compose it of, what standards should you be leveraging, and that team might be different, or at least partially different, than the team that's actually going to put it together or the tech that's actually going to put it together. They are separate exercises. In IT software, we have architects who are different than developers. Now, some architects also develop and some developers also architect, but they are two separate disciplines, and in most mature spaces, they are. The person who designed my house probably isn't the guy who drove the hammers into the wood. These are separate disciplines, and if we're going to do this right, if we're going to do this in a way that doesn't build up technical debt, we need to respect that part of the discipline that comes from the IT world, but must inform what we want to do in the OT world. This is how we bring these spaces together. And like I said earlier, the tension between the two, the tension between the design and the reality, is a productive and healthy tension that can help you land on a better outcome.
So more collaboration, right?
Yeah. IT and OT together, not warring against each other.
And, tying this back to a conversation we had on a previous podcast with Mike Labhart, innovation needs room to try things and maybe mess up a little bit. And
yeah,
right?
absolutely.
And I think that because some of these transformation programs are on such aggressive timelines under all this pressure, but if you can plan ahead, yeah.
The beauty of software, and this is non-instinctual for people who grew up from programming PLCs. The beauty of pure software is that iteration is not expensive or dangerous. 100% when you're programming a PLC, you want to do that either against a good simulation or with a good shakedown, because people's lives depend on, when I press E-stop, it stops. And so that's a good instinct to bring to the table. Like the stakes are high for doing it well, but the IT instinct that's also worth bringing to the table and understanding how to do right is that software iteration is not dangerous. Software iteration is not expensive. You can try things in pure software. You can iterate on your UNS. You don't have to get it right the first time. Because it's an abstraction layer, it protects kind of both sides from churn on either side. So at some point, there's going to be a V1. You're going to have to ship, but there can always be a V2. You can always make adjustments on the software side. It's not as high stakes as programming at PLC. You don't have to get it right the first time. It can be a journey of learning.
Awesome. Any closing remarks, Jonathan, from your side? And if people want to get involved with CESMII, how do they do that?
Yeah, like I said, CESMII has a membership model, so we'd love as many members as possible. Members help each other. Members help CESMII. But you can interact with CESMII without membership. The work that we do on GitHub and in other public forums. The consortia that we work with, if you're not based in the US, have a similar model. If you're not sure what's kind of the right point to get started, reach out. We have nothing to sell. We literally want to try to help all boats float. If you have questions coming from the UNS world, or you got started on your UNS and you want to kind of take it to the next level, I think a level of thoughtfulness is something that we bring to that conversation. There's really good concepts there, but to make them scalable and repeatable and truly unified takes an extra level of rigor that not every practitioner brings to the table. So we'd be happy to have those conversations as well. And I think finally having this conversation is healthy, and applaud you guys for doing it, and your listeners for tuning in.
Thanks for coming on board and educating us. Really appreciate that.
Thanks for having me.
You share a wealth of knowledge and definitely appreciate the time. Well, thank you everyone for tuning into this episode of Practitioners Unplugged. We hope you found these stories and insights as inspiring and informative as we did. Don't forget to subscribe, leave a review, and share this podcast with your network. Until next time, keep innovating, keep transforming. Thanks again, Jonathan.
Thanks, guys.